Okay, today we're going to talk about geometric sequences. This is section 6.6 in your book, page 193 of your student journal. What I'd like you to do is work with a partner. I want you to go ahead and complete exploration 1 with them. Do your best. I'm going to get about 5 minutes to go through as much of that as you can, please. Off you go. Hey, ladies and gentlemen, need your attention up here.
Yep.
Hey, following directions, 2 equals, that's step 1. At step 1, we get a 2. And then we go times 2, we get a 4. And then we go times 2, and we get, and then times 2, we get, and then times 2, we get, okay? And then we go here, we go 64. Then we cut it in half, we get, and then, okay, so you're just following the instructions. You make your own pattern, but part A involves geometric sequences with a common ratio of 2. What's the common ratio in part B?
3.
Okay, let's go back to A. Common ratio of 2. You're multiplying by 2 every time. What's common ratio in part B? 0.5. Yeah. Multiplying by 0.5. Now, part C is whatever you came up with. All right. Any questions there? Yeah. Oh, yeah, it would be. Yeah, you multiply by 3 each time. I didn't realize they gave you that. Very good. Okay. Let's go to exploration 2. Take a look at that. We're going to reference back to common ratio here in a minute, but I want you to go ahead and read through exploration 2. Go ahead and go read through it and try some of those. Hey, part A. Hey, part A, how thick will the paper be when you fold it in half once? Yeah, 0.2, right? Okay, you double that. When you fold it in half twice? 0.4. Fold it in half 3 times? 0.8. You sure this is 0.4?
2 times 2 is 4.
How many got 0.4 here? How many got 0.8 here? Okay, so you're just doubling it each time? Okay, very good. And then, who was able to get more than 5 folds?
I got 7 exactly. Couldn't go any more.
Dude, all right. Okay, how many were able to get more than 8 folds? 8 folds? Well, that doesn't count. You got to fold it in half.
If you fold it and then size a piece of paper in half.
No cheating on it.
You will only get.
Okay, how many were able to get 6?
Until you fill up an entire.
Keep your hand up. 7.
And then you can hold it way.
8. 8? 9. All right. What was happening as you kept folding the paper? Harder and harder and thicker and thicker. Okay, greatest number. It sounds like 7 was the most. Okay, except for Jillian got 8. Well done. Okay, I need everyone's attention back here. Done talking. So, if you have 7 folds, what is the thickness of the paper?
12.8 millimeters.
Good. 7 folds is 12.8 millimeters. Okay? 12.8 millimeters. Now, you can just continue the pattern, right? You can go 0.2, 0.4, 0.8, and then just keep continuing it. Anyone figure out how to find that out without continuing it? Everyone use the formula? No? Okay. Do you agree with this statement? If it were possible to fold the paper 15 times, it would be taller than you.
No.
No, it's not.
Let's go.
Take your butt out, guys. Come on. I know you're getting like special instructions from Secret Service, but right now you gotta focus on it. They don't care. Okay? What do you think? 15 times, would it be taller than you? No?
It wasn't even taller than that.
I want you guys to figure it out. Figure out what the height would be if you went 15 times. Hey, ladies and gentlemen, what would the height be 15 times? Logan? Okay, so if we continued with the pattern, we'd have 3,276.8 millimeters. Just so we know, that is 3.2768 meters. So for those of you like not doing conversions, just think of it this way. First, there is, if I move this decimal, there are 1,000 millimeters in 1 meter. Okay, there are 10 millimeters per centimeter and 100 centimeters per meter. A meter stick, right? Like a yardstick. Well, think a meter is about 3 yards. Or excuse me, about 1 yard. A meter is about 1 yard. How many feet are in a yard? 3. What's 3 times 3? 9. You are about 9 feet tall. In fact, these guys up here did calculate it. Back there, it sounds like over 10 feet tall. Dude, so would this be taller than you? Yeah, man. Approximately 10 feet. Isabella? Well, the paper you were folding continued to get thicker, right? So if you kept folding it 15 times, it's going to keep continuing at that thickness. It's going to be taller than you.
It'd be a really tiny.
What do you mean it can't be taller than this?
It's theoretical.
Right, but go ahead and take the paper you folded and set it right next to it. It's taller than it already. Every time you fold it, the paper gets taller.
Not enough mass in the paper.
I think you're saying longer. It's getting thicker each time. Right, you don't have enough paper to get that high. It's tough to get there, right? Couldn't be able to get there. All right.
If you had a big enough sheet of paper, you could.
Okay, we're done. Hey, I want you to turn and look at the next page of your student journal, please. Page 195. Jason, turn around now. Okay, on page 195, I want you to read about a geometric sequence, which is what we've been dealing with, and make sure you can define in your own words what a common ratio is, please. Okay, you got about a minute. Okay, can someone tell me in their own words what a common ratio is? Sarah can? Bailey can? Anyone else? Quentin can? A couple of you can? Tell your neighbor what you wrote. See if they wrote the same thing.
Is it rate of change?
Does it change? Cool. Might get confused with other stuff. All right, make sure you're ready. I'm going to call on one of you to share your amazing words of wisdom from your neighbor. Okay, Zach, what did you get? Or what did your neighbor get? Brian, don't hang him out to dry, man. Well, didn't you already tell him? Oh, did anyone tell you that? Oh, poor Zach. Sitting at the same table? No? All right. Brian, go ahead. Very good. It's like what the number is being multiplied by. In fact, it is what the number is being multiplied by. Not even like it. Okay? How many said something like that? Well done. Okay, that's what it is. Common ratio is just what you're multiplying by every time. Hey, there's an equation for a geometric sequence. Like if I said, hey, I want you to find, like if I gave you this sequence here, I said 1, 5, 25, 125, 625. What am I doing every time? Multiplying by 5. Common ratio is 5. Okay, so I've given you the first, the second, the third, the fourth, and the fifth term of the sequence. I want you to tell me the 12th term. Rather than actually multiplying that many times, the other way of doing it is to use this formula. So if I want to find the 12th term, which we call a sub 12, how many remember doing this earlier in the year? Remember, a sub 12 just means the 12th term. Mathematically, has no bearing. It's just saying you are finding the 12th term. That's what that says. A sub 12 is equal to a sub 1. Tell your neighbor what a sub 1 is. Why is a sub 1 1? It is the first term. A sub 1 is 1 times r. What's r? Ratio, common ratio, which is 5, to the n minus 1, which is 12. That's n minus 1. So on your calculator, I want you to do, remember we ignore this side, 1 times 5 to the 11th power. Or just 5 to the 11th power. I know you guys have it. Obviously, everyone in class. But right now, I want everyone to do it. You guys got it? Did you do it this way? Yeah. Bailey did it before I did. This way?
Yep.
Nice job, man. Did you guys get the same thing?
Yeah.
Let's see if Quinn got the same thing. Okay, show your neighbor what you got.
Nope.
What? Make sure. Figure out what's going on there.
Did you guys get that?
Oh. I didn't use the fire.
All right, Kaylee, what'd you get?
I got, just a minute. Oh, I'm sorry. I got 488,281. Or no, I said that.
48 million.
48,828,125. That 800, yeah, that.
All right.
That worked.
Got a little extra space there, but that's okay. Yes? Why do I minus 1? Because there is. And I'll go through that pattern with you. Okay? Right now I'm going to stick with that. But there is a reason why you subtract 1. Okay? Okay, I want you guys to... I'll prepare a way to explain that. Make it a little easier. I want you guys to take a look at page 196. All right? Right now, you need to complete the first column on page 196. Columns run up and down. Okay? Off you go. 1, 4, 7, and 10. Just really quick, to answer Jilly's question why it's n minus 1. So, Jilly, if we look at this, like 5 to the second power, like if we just use the number up here, that would give me 25. 5 to the first power gives me 5. 5 to the second gives me 25. 5 to the third gives me 125. 5 to the fourth is that. So probably the easiest way to explain that is you're always 1 further. You're always 1 ahead in terms of your power. So you got to subtract 1 to shift that back. Okay? McCoy? So, 1 second.
Your calculator just died.
Oh, you sit on my desk, please.
Okay.
Hey, you'll need this one too, Gunn. That's the next page. Hey, let's go ahead and check these last ones out here. Or are these first couple out? The first one, what are we doing each time? Okay, X, what are we doing each time here? Good, we're multiplying by 4, and since it's alternating positive and negative, we're actually multiplying by what? Negative 4, okay? So we're multiplying by negative 4 every time, so therefore this is geometric. Number 4, are we adding a common amount or multiplying a common amount? Yeah, what's your question on the first one? Yep. So when I multiply 1 get a 4, I get negative 4. When I multiply negative 4 by negative 4, I get positive 16. Yep. So number 2, the answer is neither. It's neither adding the same amount or multiplying by the same amount. Okay, number 7. Next 3 terms. What are we multiplying by? 3. Okay, so 189 times 3 is 567. Okay, Mercedes, 567 times 3 is? Okay, and Vincent, 1,701 times 3 is? Not quite 569. Someone at his table, help him out. Christina, you got it? Or Lexi? Sergi? 569, so 1701 times 3 can't be less. Isaiah, you got it? Okay, 5,103. Well done. Okay, good. So just multiplying by 3 every time. Okay? Any questions? Let's go ahead and move on to number 10. Okay, on number 10, we're going to go ahead and make our graph here. So we got our X and Y. On all of these, we're just going to graph the first quadrant. So we can just draw our XY axis right there. The difference is we're going to have to be able to plot all the points on there. So right now it says to find the next 3 terms in the sequence, which means we need to continue going downwards there. And I'm actually going to kind of build a table out of this. Just like that. I'm just going to add my own little lines. So I need the next 3 terms. So go like that. So what this says n here. When n is 1, or my first term, I get 12. My second term is 6. My third term is 3. My fourth term is 3 halves. My fifth term. What's the next term? 0.75 or 3/4. Okay, so what are we doing every time here? Good, we're cutting in half every time here. So half of 3/4 is? 3/8. And half of 3/8 is? 3/16. Notice the bottom number just is getting cut in half when you're dividing by 2. Okay, so as I'm plotting these, Isaiah, Brian, you guys good? So what should I go up on my y-axis? Yeah. Go up by 2. Okay, so that would put me at 20 right there. X-axis, what should I go up by? Yeah, 1, right? We got 1, 2, 3, 4, 5, 6. Okay? We got 1 and 12, 2, 4, 6, 8, 10, 12. All right. We've got 2 and 6. 3 and 3. 4 and 1.5. That's 2. There's 1.5. Okay, and we just kind of keep cutting that. See this distance between these 2 points? This distance is half of that. That one's half of that. That one's half of that. The points kind of get closer and closer together. Do they ever hit the bottom line? No. All right. Do I draw a line here? Is this continuous data? Can I have a 1.5 term?
Mhm.
No, I can't. This is not continuous data. Okay, we can have the first term, the second term, the third term, the fourth term, the fifth term, the sixth term. We can't have the 6.5 term, the seventh term, and so on. All right. Any questions? Okay. Why don't you turn the page, please?
So go to page 197, or actually turn the page to 198.
Actually turn the page. 198. Okay, you guys are now on page 198. On page 198, write an equation for the nth term of the geometric sequence. We're going to go through this first one. I want everyone to figure out what our common ratio is.
You said 198 and you're on 198.
No, 197, thank you. Sorry, 197. Tell your neighbor what the common ratio is, please. So we're going down, we're dividing. Dividing by what? 3, which means we're actually multiplying by 1/3. Our common ratio is 1/3. All right, write an equation for the nth term. That is where we're using this formula again, right here. A sub n, write it at the top of your page. A sub n is equal to A sub 1 times r to the n minus 1 power. So, write an equation for the nth term, that's A sub n, is equal to, tell your neighbor what A sub 1 is.
6561.
Good, 6561, that's A sub 1. It's just the first term. R was 1/3, so we need to know A sub 1 and R. N we don't know yet, minus 1. That is the equation. Now, do they tell us to find another term?
Oh, yeah.
Go. A sub 6. That means we just, for n, we put 6. So A sub 6 is equal to 6561 times 1/3 to the 6 minus 1 power, or to the 5th power, right? Okay. Tell your neighbor what you get there. And we get 27. All right. Hey, your assignment tonight is to finish 1 through 15 in your student journal on pages 196 and 197. 1 through 15.
Good thing I did number 8.